Stanger, and this is Office Hours with James. I'm very pleased to be here. This is James Stanger. I've got some helpers with me, Mike Sutton and Leanne Van Wagener. Leanne will be looking to answer questions. And so as we go along here, we have several hundred people signing in here. Just want to set up a couple of things and do some housekeeping first. First of all, you're muted by default, so we can't hear you. And we very likely won't be able to hear you. The other thing is we want to make sure that we make things as interactive as possible in this session. So the first thing I'd like to do is, and by the way, yes, happy Pi Day, Stephen. Thank you very much. It's Pi Day 3.14, right? 3.14. So everybody should go have some Pi today. What I'd like to do is see if you can hear me. Can you hear me? Just say hi. Or you could also tell me where you're calling in from, or dialing in from, or webbing in from, or whatever. I'd like to just make sure I can hear you. So San Antonio, Stephen, there we go, from Franklin, Indiana. Portugal, a local person. Rodrigo, how you doing? So, okay, I can see that you can hear me. Madison, Wisconsin, Stephen. Well, thank you very much. Now, as you have questions, we'll be able to take a look at those questions, but we have so many people on board today, I won't be able to get to all of them. So please try. You could be insistent, ask a question a couple of times if you wish, but try not to be too disappointed if we can't get to all of your questions. So today, folks, this office hour, we're going to be talking about technical skills for managing risk. We're going to be taking a look at putting analytics and some pen testing and some threat hunting into context. We're going to be going over a couple of applications. First, we're going to be talking about important perspectives that you should have in regards to things such as pen testing and analytics. So we have a few people on here. So here's Leanne. So you could go ahead and put your questions into the Q&A window down below, and then Leanne will be able to take a look at those. We have an hour, so I'm going to look to see if I can present for about 40-50 minutes or so, and then answer any questions near the end. It's very possible that Leanne will be chiming in and asking questions as we go. So just so you know, this is approved for A+, Network+, Security+, Cloud+, CYSA, used to be CSA+, now it's CYSA+, and CASP. So it's approved for all of the CE eligible certifications that we have. I'm James. For those of you who don't know me, I'm the Chief Technology Evangelist for CompTIA. I'm responsible for working with our product managers, responsible working with exam development and with the executives here at CompTIA to make sure our certifications are what they are and that our certification offerings are cutting edge. Done a lot of work over the years in security analytics, etc. So I'm happy to be here today. Here are the things that we're going to be talking about a little bit. Risk management, a little bit about threat hunting, a little bit about analytics. And I'm going to get right into sharing my screen here eventually and talking, I like that, getting right into something eventually. Eventually, I'll be getting into sharing my screen, showing you a few applications, things like Nmap, NTOP, and a couple of other fun little applications. So let's go ahead and get started here. And the first thing, the next office hours with James. You can Google this. You'll also see an announcement of this at the end of the presentation where you can sign in. Next time in April, we'll be using a platform On24 instead of WebEx. And the next one, we'll be talking about essential networking skills. Sometimes people want to go stampeding into security without first getting their networking skills. I wanted to hit that a little hard next time and go over some essential networking skills. And that's approved as well for all the certifications that we have. So moving on here, let's talk about risk management and threat hunting. What I'd like to do before I do this, I'd like to learn from you real quick. In your opinion, and just type it into the chat window, what is risk management to you? What does it mean, risk management? I'm curious, because this is a very important thing. Stephen Bedelia, thank you. Yeah, I'm 24. There you go. What is risk management? Type that in. Yeah, being aware. Good, Joe. Identifying errors with mitigations. Good, good. What is a definition, I'll say, of risk? The whole idea, folks, of risk is there you go, assessment plus risk mitigation. Okay, very good. Keeping threats to a minimum. You know, when it comes to understanding what risk is, folks, it really comes down to identifying issues, right? Identifying where your network can be attacked. And I'm very interested in the concept of threat hunting and risk and understanding where it goes. Because one of the things that your board, and when I say your board, I'm talking about your board of directors for a particular organization, or your CEO, your CISO, all of those folks, they're going to be very interested in how their systems can be attacked and how they can lower the risk of downtime. So the idea, folks, when it comes to risk is basically, it's a very, how should I put this, context-specific thing. So you can talk about risk as something where you're, well, what risk is, James, is the ability to take a look at whether you have a threat and whether, which is a threat actor, somebody out there going to attack you. And then you have a vulnerability, so a threat plus a vulnerability, that equals risk. That's a more technical approach. What I'm interested in doing today is taking that technical approach and moving from a mere, how should I put this, reactive approach into more of a proactive approach. Over the last year, 6 months to a year, I've been talking about and talking to people about the concept of threat hunting and risk. A threat hunter is somebody who goes in and instead of just waiting, setting up a couple of alerts in a firewall or what have you, or an intrusion detection device, what they do is they spend a lot of time learning how the business works. And by learning how the business works, it's not just scanning systems. They actually start interviewing people in departments. They say, well, when you communicate, what tools do you communicate with? How are decisions made, and how are those things communicated? Because today, one of the top risks that is happening throughout the world is the problem of social engineering and the problem of ransomware and how all of this gets introduced. What happens is attackers find ways in which, as systems are put together and as people communicate with each other, there are all sorts of gaps that happen. And I hate to use the word gap sometimes, because a lot of times in the security world, the term gap analysis is used. And gap analysis simply is meant to mean, okay, we have a certain standard of compliance, and we are X points or X amount of time away from meeting that standard. So we do a gap analysis to say, well, here's our goal, and here's how far away we are from our goal. I'm not talking about that kind of gap. I'm talking about the interstices, and that's a fancy word for meaning places that reside in between, where one technology connects with another, the in-between places. And here's what I mean. There are many examples of that. First of all, where meat space, in other words, where our bodies connect with cyberspace in one way or the other. One of the more obvious ones I didn't put up on that list here that you're reading is the idea of when you interface with your email or with the IM or with your with some sort of IM, you know, Slack or some sort of tool, even Skype when you do Skype messaging. As you interface with anything computer, there is an interstice. There's a connection there, and what happens is those tend to get exploited. Other examples of those can also include, for example, when a SQL server talks to a web server. We hear about the concept of SQL injection. That's where a bad guy is able to go in, and as a legitimate transaction is going on between a web server and a SQL server, the attacker is actually able to manipulate those commands and insert arbitrary code, in other words, code that he or she wants to insert, to get information out of that database. This is how a lot of credit card fraud happens. This is how a lot of times hackers are able to go in and manipulate data so that the database contains false information. So, Mr. Stonecipher just typed something in about the idea of an API. Yeah. Effectively, that's exactly right. Other examples can include back in the day when Facebook started doing a very convenient password resetting feature that you could actually use your phone to reset the password. Great idea, because the phone could act as another factor for authentication and all that, but it wasn't executed as well as we wanted to, because it used the SMS network, the texting network that we use every day. The problem being that people's passwords were being sent over the SS7, okay, network. The SS7 network was created, what, back in the 80s? No encryption there. And people were trivially, bad guys were able to listen in on those communications and grab lots of people's passwords. I'm giving you an example of how technologies, web technologies and SMS, SQL servers, et cetera, are individual, bodies and eyes, and our email interface, if we're using Outlook, for example, or whatever email client you're using, et cetera. As all of these things are used and done, we find that hackers are going after this. And a good threat hunter, somebody who does risk management, goes in and learns each of those elements within a business. And that would be different in CompTIA than, say, a company like, I don't know, Honeywell, or Google, or whatever bank, or the company or organization that you work for. I spent a lot of time talking with folks in the military, for example, and they've talked about how their particular vulnerabilities that they tend to present to the world, the attack surface, that phrase that's used, is different from one division to another, et cetera. So a good threat hunter is somebody who proactively looks at all of these elements. And it's a very different mentality than the good old-fashioned Gandalf mentality. Oh, we have our security guru who helps us, or the cowboy who comes in. As much as I love Clint Eastwood's westerns, it's a different mentality, and that has been a mentality that's existed. Now we're talking in terms of the cyber detective or the guide, who's somebody who kind of follows you along, helps you go along a path, or even a team captain who coordinates resources. So the threat hunter is involved in doing various types of activities. I call it, well, it's not me who calls it that, but the concept of deep packet inspection. In other words, they look in at traffic patterns. They look at architectures. They gather threat intelligence. What are the latest threats that are out there? And by the way, remember, a risk is really different than a threat. A threat is somebody outside the network or inside the network, but some sort of actor, that's the term that's used, who's trying to do something. And then what they do is they take a look at they recon your system. They do system reconnaissance. They do scanning, all sorts of things to try to find things. So don't get too confused between the concept of a threat, right? That's some sort of actor, and a vulnerability, which is something in your system. And it's not just one computer or a bunch of Windows computers or a bunch of Linux computers. It's how systems work together. Those can create vulnerabilities. Then you gather threat intelligence about each of these systems. You take a look at behavioral analytics. A lot of times behavioral analytics, folks, is talked about in terms of individual behaviors, how a department of people, how they behave every day. Well, we looked at their behavior on the network, and the baseline says that they're at work between 9 to 5 and not at work after that. And so we can set baselines. Very simple example. It's not just user behavioral analytics, though, folks. It's how the network itself behaves. When does a network peer? When does it go ahead, when a network connect to the internet, and how does it do that? How does it behave in terms of DNS transfers and all those sorts of things? So it's also network behavioral analytics. Then you do review vulnerability data, et cetera, and other things. And then you hunt around and you look around from a communications perspective to gain that full operational procedure. This is, you review communications between people. You get a big picture understanding, 50,000-foot level, all the way down to how the packets work. And this is a heuristic process, fancy word for saying it's circular. In other words, you start with a hypothesis, you go through, you take a look at, you investigate things, you try to uncover patterns, you do some analytics, and then you start gaining more and more understandings of things. So you create a new hypothesis about certain areas of the network. And quickly enough, through this kind of process, you're not chasing your tail, you're actually moving towards understanding how all those interstices work, how all those little in-between places work. And then you can start saying to your boss and to your boss's boss, okay, here are the problems we have, and here's how I think we can go ahead and create a solution. So you collect resources, you turn a sinkhole of information, just tons of information, into a visualized repository of information. In other words, you turn a bunch of data that's like a bunch of chattering monkeys somewhere, and you calm it down and show trends. So you turn data into information, better way to put it. And so you can give a big picture if that's necessary, but you can also drill down. And you can use various tools for this, folks. You can start with packet capturing tools and Wireshark. You can get as fancy as Siem software, security information event management software, which is basically software that captures logs from various resources. You can capture it from firewall logs, intrusion detection logs, even individual host logs, server logs, etc. And it creates a larger picture. So the software should look inside of IP sessions. It should show trends. It should show how protocols work in real time. It needs to be visual. By visual, in other words, it needs to show how things work. It needs to show connections, because your job, and I'm being facetious here until artificial intelligence replaces us all, your job is to look for trends and to make sure that you can relate all of those things that are happening out on the network to risk, to threats, and how you can mitigate these things. AI, by the way, is going to help us do that for a long time before it replaces us. But anyway, so you should reflect, the reports that you create should reflect the heartbeat of the network and create context and situational awareness. I'll go quickly over this slide because I think some people on this have already seen this before. Visuals are very important because if you look at it this way, there's a Wireshark packet captured there, and that's showing a BitTorrent connection. In the front there is a tool called EtherApe. It's a Linux tool. You can Google for it, ETHERAPE, and you can download it and use it. That shows the same thing. Now, if you had to show that, and for anybody who's not seeing the screen, by the way, go ahead and refresh your screen. You should be able to, there we go. You should be able to see the screen. It's basically says threat hunting and visuals right now. I'm on slide 11. The whole idea is that the one packet capture there, they're showing the same thing. Which is most visual? Which is the one that would help somebody who's a little less technical or awfully busy to understand context? Well, clearly the one showing all of the different protocols and which one is being, which system is communicating with which in a visual way. So the whole idea when you're managing risk, you have to make sure that you understand how to communicate to technical and non-technical people in such a way that your hair is not on fire and that you're not giving extraneous details, that you're showing context. I'd like to go over this particular section now real quick about the hacker lifecycle, because I don't think we should go stampeding into understanding tools and how to use them unless we can map them to the hacker lifecycle.
Hey, James, before you go on, just a question that came, I wasn't sure if you saw the question that came in about, so understanding infrastructure and the corporate company culture structure and learning the intricacies is crucial. And then also, does CompTIA have an ITIL-like certification?
You know, it's a great question. We do not have an ITIL-like certification. We've talked with Axelos, the people who own and run ITIL. Yeah, it's a very important understanding to see, a very important thing to understand how things connect together. And for those of you who don't know what ITIL is, ITIL, you can Google that later on. It's basically a certification series of training that goes in and shows how different systems work together. So a lot of times people tend to get very, well, compartmentalized, siloed in their thinking. Oh, well, there's networking professionals, and then there's server professionals, and then there's people who are over the sales CRM, and there are others who are business process people. ITIL finds a way to show how all of these things work together. So we don't have a certification in that. We tend to focus on the tech side of things. That's why Help Desk for A+, Networking Administration for Network+, Security Professionals for Security+, Analysts for CYS A+, that sort of thing, and the upcoming Pen Test Cert for pen testers. So you have a red team, blue team sort of approach. We do not have an overall sort of approach like ITIL. Great question. Other questions, Leanne?
I think that is all. Oh, actually, here a couple other ones that have come in. What's the software visual for threat hunting that you mentioned?
The software that would be used as a category, it's Siem software, S-I-E-M. And an example of that could be something like Splunk, S-P-L-U-N-K. Another, and I'll be showing a couple of threat hunting type of pieces of software here shortly. Any other things that you could use, OSSIM, right? OSIM, that's another particular SIEM tool. There are many of them out there. IBM sells one. Any sort of software that some people might think like Bro, B-R-O, or Snort are SEIM tools. They aren't. SEIM tools can take those Bro logs, the results of a scanning tool such as Bro, an alerts tool such as Snort, and then start to process those things. A SIM is not an end-all, be-all. It doesn't solve your problems. If you don't use it right, it'll cause more problems than anything else because it'll just give you garbage information. You have to make sure that you configure these things correctly. So there's some questions about SIMs.
Yeah. And then just a comment that came in from Christopher saying, this to me is the necessity of Network Plus in having network diagrams and such.
Say that again. What's a necessity?
Well, I wasn't sure what slide you're on when he was referring to it, but he said this is to me the necessity of Network Plus in having network diagrams and such.
Absolutely. Yeah, it's so funny that you bring that up. Is that next time, as I was creating this presentation, I was thinking to myself, gosh, I should have done networking first and then done this presentation in April. Because a lot of people, again, want to stampede right into security without understanding how communications at, how information in motion, there's data at rest and data in motion works. And you really need to understand how all those networking devices and networking architectures work together. Because if you're going to talk about the kill chain concept, and I want to make sure people are seeing this. It says, there's a graphic here that says the cyber kill chain and another graphic that says task. I want to make sure people can see that. I hope they're seeing that. You won't understand how the cyber kill chain works unless you understand the endpoints, meaning all the hosts on your network, from mobile devices to IoT devices to desktops, mobile phones, all the way through, though, to understanding how those networking devices connect those endpoints. And by networking devices, I mean switches, routers, all the fun stuff, but firewalls and things. So good. I'm glad the slide's showing up. So yeah, it really is important to understand your networking. That's why next time, if there's anything that was particularly mysterious that I said about networking, we'll be going over some, I think, some really killer knowledge about the importance of good network troubleshooting and architecture skills. We'll be talking about cloud and traditional networking as well. Thanks,
right.
Thanks, Leanne.
Yep, and then one more question before we move on and follow up on the SIM tools available, the SIEM tools. Which ones are available for home networking use, and or which ones do you recommend? And are they open source, or is there a purchase required?
There are open source tools. A lot of them, for example, OSSIM, that's what it's called, OSIM. That's an open source one. For home use, yeah, go with the OSIM and a couple others. A lot of these tools, though, are really, guys, created for enterprise folks. And by enterprise folks, I mean they want to charge you a lot of money for them. One tool is by Gartner. It's called SIEM Magic Quadrant. That's just an example of a SIM tool. There's Micro Focus by ArcSight. There's Alien Vault. Alien Vault is the one that is an open source tool. Let's put it this way: the Alien Vault folks have a for-fee one, right? And they also have a for-free one, right? And with the for-free one, of course, they're always trying to, they'd like to upsell you into that one. Nothing, good or bad about that, just the way it is. There's Logarithm, SIEM tool, Logarithm. McAfee makes one. SolarWinds makes one. There are many of them, and you can Google for them. As far as my recommendation for them, I can't recommend any one of those. I've used the Splunk one before, very cool. I've used the Alien Vault one, the OSIM one, very good. I like it a lot, but gosh, they all have such strengths. So there you have it. Before we get into Siem tools, though, I think there's a lot of other tools. And another one, again, is SolarWinds. RSA Net Witness Suite is a real good one. Before we get into that, though, I think it's really a good thing to understand the idea, if not of the kill chain, to understand the hacker life cycle. This is something that I'm going to be blogging about in the future because, and I'll say this right now, a lot of times security professionals tend to think along the lines of this. They tend to think along the lines of, oh boy, if one hacker gets through, if one hack gets through, then all is lost. And that has been summarized in the security industry. I certainly haven't come up with this concept as the defender's dilemma. If you're a defender, and all of us, I hope, are being the good guys, the dilemma is, wow, if one thing gets through, I'm going to lose my job, or the company's going to get damaged, and a much better way to look at it. I think that it's a better. The industry is slowly realizing it's not so much the defender's dilemma, folks. It's the attacker's dilemma. Think of it this way: an attacker is going to follow a certain pattern. I don't care how sophisticated that attacker is. It could be somebody sponsored by a state government, whatever evil state government that you can think of. And I don't mean states in the United States. I mean a state, a country, right? Or a gang, or a well-funded enterprise. I don't care who it is. They're going to follow certain patterns. And the Lockheed Martin folks came up with the cyber kill chain like 8 years ago, or at least they published it 8 years ago, back in 2010, and they called it the cyber kill chain. If you look at this graphic, the whole concept is that hackers will conduct reconnaissance. Then they'll, as they learn about systems, then they will weaponize things. They'll say, well, okay, I see that the company has a certain communications vulnerability, and I'm going to take a tool, whatever tool that is, and I'm going to map that tool to a vulnerability, and that's the weaponization. Then they deliver that in there to the system. Let's say it's a bit of ransomware that they've delivered through a phishing attack. That's step 3. They deliver it in there. Then they start exploiting what happens. So as there is a containment failure, that ransomware doesn't get caught by antivirus or by the layer, hopefully the layered defense system. Then an exploit starts happening. Then installation of the software happens throughout the network. You have command and control happening. You have a phrase I like to use a lot, lateral movement taking place. In other words, they grab one system, then they go along and they grab every other system that's similar, using trust relationships that are set up between servers or PCs or devices. Then they take action on the objective. Is the action on the objective to deliver ransomware and then to, extort money? Is it to grab personally identifiable information, like with the Equifax hack or whatever? Is it to manipulate data, and not just steal it, but to manipulate data? All of this stuff, right? That is an example of the cyber kill chain. It was a concept taken from an old military concept of basically called F2, find, fix, right? And then T2, to track and target, and then EA, engage and assess. This graphic here down to the side of the cyber kill chain. That's an old military concept, the idea of to find, to fix, to track, to target. And they kind of went, that's an interesting pattern. What pattern do hackers work? Is it, there's been a lot of discussion as to how useful that model is or not useful the model is. A lot of folks, and this is what I got from those of you who have attended an IT Pro webinar in the past, this is just another example of somebody's idea of a kill chain. This is Target's understanding of a kill chain in a sense. Notice where it says in this graphic, the targeted attack life cycle. So I didn't come up with this. This is an industry example. Notice where it says initial compromise, and then the hacker's going to establish a foothold, and then the hacker's going to escalate privileges, and then conduct internal recon, and move laterally, and maintain a presence, and then complete the mission. Whatever that mission is. It could be to steal credit card data. Could be to any number of things, to manipulate data. The whole idea here is that as you look between, and it doesn't matter in my mind whether you're following the Lockheed Martin kill chain approach or something that's customized to a particular retailer in this case, what does matter is that you take a look at how that attacker lifecycle works in your organization. That's what a threat hunter does. I use the term APT, that's Advanced Persistent Threat. An advanced persistent threat is an attacker who does more than just smash and grab. They actually come on in and they basically live inside your system, and they will and sometimes for a period of hours and days. A lot of times we find that I've noticed that people, when it comes to advanced persistent threat, this means that somebody is lurking inside of your systems. And the amount of time, the average amount of time varies, but one of the rules is that a lot of times people who are engaging in sophisticated attacks where they're lurking in your systems, they'll be in there for 40 days, between 40 and 80 days. Now, I was talking to one security professional who was saying no matter how the most skilled individual, probably once they get into a system, will probably take at least 2 hours to kind of become aware that the system has been compromised, and then to take a next step. That's most of the time it takes longer than just a couple hours for somebody to start exploiting data. My point is that 40 days, right, if you divide that down to, say, 4 hours, right, for somebody to spread from one system to the next, it kind of gives you an idea about how quickly people can go along and attack systems. But when I was talking about the concept of the defender's dilemma versus the hacker's dilemma, it's not so much the defender's dilemma to think about, it's the hacker's dilemma. Because each time a hacker does an initial compromise and establishes a foothold and escalates privileges and takes these steps, they're going to leave stuff behind. When I say stuff, logs. They're going to leave traces behind. And as you are a defender, your job is pretty much to take a look at what those traces are and how you can detect and respond to those traces. Lockard's exchange principle, it's an old principle, means that an attacker who comes in, whether it be a physical attack or a cyber attack, doesn't matter, will leave traces. And the idea is, how can you detect those traces of an initial compromise? How can you detect, even before then, how can you detect traces of a reconnaissance? How can you detect traces of where people escalate privileges? That's where a Siem tool can help, or an intrusion detection tool can help along these lines. And if you set your controls to mitigate and to mitigate these each step along the way, whether you're using the Lockheed Martin tool or a custom tool, and I'm really big on the idea of using custom frameworks. You start with something, and then you customize it to your network. You can then become a little bit more aware and set proper thresholds and that sort of thing. So when it comes to the skills necessary for this type of thing, you're going to need security analytics to understand how to become aware of threats. Sim tools, yes, but really you're going to have to focus on the types of skills that are listed here in the skills summary. Hey, Leanne, did you have a question?
Yeah, sorry, just before you move on to the next slide, just a quick question about the kill chain model. And does it apply to RISC, RISC, or mobile?
Great question. I wouldn't say RISC. RISC is a platform of computing, RISC chips and that sort of thing. RISC. I'm talking about RISC as in risky business, as in basically trying to identify where threats and vulnerabilities map together, match up.
Great. And then as far as mobile, same.
Well, mobile, certainly mobile, I'm not sure I quite understand the question, but mobile tools or mobile BYOD devices would certainly be part of that equation. Yeah, absolutely. But I'm not talking about particular architectures, like RISC versus CISC or anything like that.
Okay, great. Thank you.
You bet. So when it comes to understanding, let's map applications to the life cycle. Let's get to some fun stuff here. Nmap. When it comes to using Nmap, folks, the whole idea of using Nmap isn't just to scan systems. What are you guys tell me, what are we trying to do when we use a tool such as Nmap? And for those of you who don't know what Nmap is, you can Google it, nmap.org. It's a tool that's been around for 20 years, and it has morphed and changed over time, and it's still worth talking about. But you don't have to use just Nmap. You can use tools that are readily available. For example, if you're on a Windows system, if an attacker was on a Windows system in a company, and that Windows system is attached to a domain, there are all sorts of domain tools that are installed on that Windows system. My point is that almost any end user can use those existing tools to start conducting network reconnaissance on a system. You don't necessarily need Nmap, but Nmap is very, very useful. One of the things I'd like to show here in regards, and the whole idea about the life cycle is, so here's my question to you. When it comes to a tool such as Nmap, again, very useful tool, as long as it's used right. And by the way, I don't want you guys going out and using Nmap to scan other people's systems. Don't do that. That's aggressive, and you're crossing a line. Don't do that. You can scan your own systems, and I don't mean your own companies either. That's also wrong. If you have your own system, your own computer that you've set up, scan that. Don't scan anybody else's, please. Okay. What you can do is basically create scans that have the ability to either discover multiple systems on a subnet, or to fingerprint and scan an individual system and find out what ports are open. So you can use Nmap to conduct what's called a ping sweep, or a sweep using whatever protocol you wish. What's powerful about tools such as Nmap is that it has the ability to use ICMP or UDP or TCP and various protocols to, again, identify all of the networks, computers on a network. And by computers, I don't mean just desktops or servers. I mean anything with an IP address. And then once you've discovered all those, let's say you've discovered a network that has 200 systems on it, you can then start scanning each of those individual 200 systems. So one of the things that you can do is basically look and see how, in this case, I've given a couple of examples about how a Nmap has scanned a system and has taken a look, and it notices that, for example, port 80 and port 22 are open. Nmap can do more than just show an open port. Using the Shodan API, Shodan basically creates a database of weaknesses and openings and issues. It can basically, if you use this API, and you have to go to Shodan, I think it's shodan.io, you have to go, just Google for it. You can create your own key, and you can use Nmap together with Shodan and take a look at getting very specific information about a specific service that's open. So in this case, port 80 is open, and it's able, using the Shodan API, is able to go in and discover that not only is port 80 open, but Apache server is listening. In this case, port 22 is also open, and Shodan was able to show that OpenSSH was open, and we had a specific version of Debian that it is open to. So you can now start taking a look, and what I want you to do now is, as I've discussed this, what step along the way, and I'll show the kill chain again real quick. What step here is being conducted? Is it step 1, step 2, 3, 7? Which one?
And James, while folks are answering that, can you just clarify? Someone was asking, is that Kali Linux in the image?
That is, yes.
Okay.
I was using Kali. Wait a minute. I'm not sure there that I was using Kali. Let me take a look at that real quick. And by the way, yes, it is step 1. This is a classic reconnaissance step. Yes, I was using Kali on that one image, yes. And the second one, I probably was using, it looks like Ubuntu, actually, I was using on that second one.
Okay, great, thank you.
So, yeah. And so if you, so this is just an example of using not just Nmap, but using Nmap in conjunction with another service. And what you're going to notice is whatever tool we use to talk about reconnaissance, right? And here, by the way, is how you can install and run Nmap if you don't have it on a Linux system already, right? You want to make sure that on Ubuntu, for example, the deb packages, debian.org stable Nmap, that is included. It may work in other ways. Linux is a little slippery sometimes. There's more than one way to do things. But I have noticed that at times if you use apt-get to install something, it says, I don't know what nmap is. If you add that repository, it'll work. Not only would you have to update the apt-get daemon, the sources.list file, but you'll also have to make sure that the daemon rereads that file. And those are the commands for that. And so that's how you get to nmap installed. So that's just one example of a reconnaissance tool, okay? There are many others that are much more visual, right? And I won't dwell on this slide before. The whole idea, folks, is that this is a place where I went walking here back in October. It's called the Quadrant, and I'm going to say that wrong, but it's on the Isle of Skye in Scotland. Wonderful place to walk. You're looking at two versions of it. One, a picture that I took of it. The second one is actually a map, a topographical map. Topographical? Topographical map of the exact same location. The whole point, it asks, well, which is most informative? Well, the answer is both, okay? Because the whole idea is that using visualization, you want to be able to show how different different things work. And again, you're looking inside of IP sessions, you're showing connections, you're showing the business use and the context. And there are various tools that can help you do this sort of thing very quickly. And so I'm going to go in and in the last few minutes show you a couple of examples of the types of tools that you can use. Okay, you should be able to see my screen, and I'll be showing probably an Ubuntu Linux eventually, but I'm showing a Kali Linux system. Leanne, do you see an example? Do you see the screen that I've got here? Okay. Yeah. In this case, this here is something that it looks like I conducted a scan of CompTIA.org. I didn't. What I did is I basically, because it's not my system, but I typed in what it would look like to do so, right? So sudo means that I am asserting root privileges on my Linux system, and I'm using nmap, and I'm basically telling it not to do any ping scanning, right, or any SYN scanning to make things a bit more stealthy. And then I'm using this Shodan script, and there's my key, right? And notice what it's doing here. This is actually another system, local system. I just made it look like it was CompTIA's. And notice it's basically saying, here's the version of the web server that's being used. That's just an example of the way in which you can conduct reconnaissance. But there are other ways that you can conduct reconnaissance on a system. You don't again, you don't have to use any particular actual application like nmap or whatever. You can actually use simple commands. For example, OpenSSL is a tool that is installed on any Linux system. And I am basically using the client version of OpenSSL not to generate a certificate. That's what OpenSSL can be used for, to create, for PKI, to create certificates. But I'm using it to connect to a system. And I'm here connecting to, in this case, and I'm not scanning CNN. I'm basically making it look like I'm connecting you to port 443. And you guys tell me what port 443 is? Yep, it's the SSL port. So I'm basically connecting like any browser would to CNN. And in this case, I am looking actually at the transport layer security, the SSL as it were, session ticket. And it's in this way I can gain information about this server and understand what kind of encryption it's using, etc. And a lot of automated applications, as they do reconnaissance, will take a look at this types of information. And it will say, well, it's using version 1.2 of this protocol, and here's the cipher that it's using. In some cases, it might notice that it's using, instead of SHA-256, it might be using a lower version, which could be vulnerable. The point I'm getting at is that you can use any number of tools, OpenSSL, or in this case, you could use something such as even Telnet. Now, I'm not telnetting to CNN's telnet port. I'm telnetting to their 443 port. Oops. I guess it would help if I used it right. And that didn't give me much information, but it'd be helpful if I could type. In this case, I'm using telnet, and I'm going to use the get command. And in this case, it doesn't give me much information other than a little bit of information about a particular proxy server that it's using. I'm just showing you the way in which reconnaissance can happen. These are things that, that you do to understand how a particular system works. But there are more sophisticated tools that you can use to learn about how network traffic works. In this case, you can use something called NTOP-NG. This is not a scanning tool. This is a network awareness tool that you would use to understand how traffic flows and how traffic works on your systems. In this case, I've been running NTOP for a little while. I haven't been able to run it as long as I did because my Windows system that I had that I'm virtualizing Linux on rebooted on me. But notice what it does is it has the ability to listen to all the hosts on a network and the types of traffic that exists. So in this case, I can go to different types of networks and how they work. This is a particular network, and it shows the breakdown of the traffic. And you can even get a fairly nice chart, if it's lasted long enough, of the different types of traffic and the spikes. In this way, you can identify ways in which people are conducting denial of service attacks on a network or unusual traffic. So it's called NTOP-NG. It's open source, freely available. There is a fee-based version that does even more sophisticated looks into networks. But it's something that it can help understand from a reconnaissance perspective. It's not like Nmap, because you don't use NTOP to go out and scan other systems. What it does is it goes in and listens passively to the network and shows you trends. See, this way you have two different perspectives. Nmap is a little bit more red team, pen testing oriented, a little bit more, whereas Nmap is a little more blue team, analytics based. Because Nmap, for example, NTOP can understand, well, here's how different types of traffic was used and the different types of traffic that was conducted, and it can actually identify that an Nmap scan was used.
Hey, James, quick question.
Yeah.
Doesn't Wireshark do the same thing?
Yes, it does. Wireshark can do a very similar thing, but here's what Wireshark will do. Let's see. Let's see if it'll allow me to open Wireshark here. I'm just doing this on the fly. The nice thing about Wireshark, folks, is that it does give you a nice packet capture. And I didn't run this with root. Yeah, I didn't think it would let me. Let me do it the illegal way. I'm just doing this very quick. When I say illegal, it's not illegal. It's it won't like me doing this. So I'm running Wireshark, and the problem with Wireshark, folks, ignore that. And I'm conducting a packet capture right now. Let me see if I can actually show. Well, maybe if I refresh this here, it'll give me a couple of packet captures here. The problem with the great thing about Nmap is, yes, it's Wireshark is that, yes, it is free. It's incredibly powerful. It gives you a lot of detail. Okay, so it shows the packet by packet sort of approach. Doesn't give you a graph. So you can get lost in the details real quick. So I'm not saying any one tool is better than the other. They have each has their uses. Looks like I've frozen my version of Nmap there. It's capturing too much data for this particular virtual machine. So in this case, as I refreshed, notice what it did. As I refreshed the web browser, it did a DNS query like it's supposed to. And then it made a SYN-based connection to port 443 to the web page that you just saw. So you're looking at a representation, right, of that network traffic. But another representation of that network traffic is, in fact, let's see if I can go here to NTOP-NG, and it's going to take forever to get there. But as soon as it does, you'll see it. You're seeing the exact same thing, but from a different level, right? And let's see. For some reason, my this is the problem with demos. The NTOP-NG instance of Ubuntu of Kali, I mean, is barfing here. It's having a hard time refreshing. So apologies for that. So the difference between Wireshark and NTOP is simply this. You have a lot of detail being shown here in Nmap, in Wireshark, and you're seeing you can drill down to the detail here with Nmap. With NTOP. Wow, one of these days I'll get my terms straight, folks.
Well, and then just another couple follow-up questions. Would it be prudent to use Wireshark for the capture, then use another tool for analysis? And then also, can we use Security Onion?
Yes, you can use Security Onion. And yes, the whole idea behind what I would do is you could start, how do you peel the onion, as it were? Do you start with the larger look at the network, like with by using something like NTOP to get that 50,000-foot view and then drill down to Wireshark? Yes. Do you sometimes start with Wireshark at the packet level, then drill up? Yes. It depends on your perspective. And NTOP doesn't really do that much network discovery in the same way that NTOP does. In the same way, that Nmap does, but so I would usually start from a 50,000-foot perspective and then get down into the nitty-gritty with Wireshark. Too quickly with Wireshark, you can get lost for all the details, and it's kind of hard to tell the difference between a successful hack or a hack attempt and just legitimate traffic. Another tool that you could use is called EtherApe. Let's see if I could run this here. Using EtherApe, and it doesn't seem to want to appear here. It'll show up shortly. The whole idea behind, let's see if I can try it again. Oh, let's see, my password, is that you can use something like EtherApe and Wireshark together. So I'll just go ahead and stop. So there's a capture there. Now notice if I were to do some sort of ping, right? I'm doing a ping there, right? You'll notice that some of that is being reflected. So notice as I do this, I'm pinging a particular system. And you can go ahead and see how this traffic works. And notice that there's HTTPS, domain traffic, meaning DNS, and ICMP being used here. So this gives you a very nice perspective. You can do the same capture on Wireshark, except it's much more granular. And then you can see the same sort of representation of traffic in something such as NTOP-NG. And so now you're combining perspectives, and you're taking a look at, well, now that I understand the complexion of the network traffic, what kind of risks are involved? You can also use other tools such as, and this is with the time that we have, probably the last one I'll be able to show, it's a tool called Maltego, M-A-L-T-E-G-O, Maltego, what a name. And it is a network reconnaissance tool. So I've been kind of stuck in reconnaissanceville here in showing you this. And what you can do is using this tool, you can go in and take a look at the relationships between various system elements. What do I mean by that? Networking. So routers, DNS, the SMTP and POP3 or IMAP servers, email servers, different domains. And you can then start to understand the business relationship between how all of these systems work. So before you go running into, well, what's the indicator of compromise? Or you go running into what are the hacks that are available on a particular system that I can fix? Take a step back and take a look at the reconnaissance perspective. And using things such as Maltego, you can go in and launch a machine. And again, these are things that you don't run on other people's systems. You run them on your own. And by your own, again, I don't care if you're a part of a company and you do not have permission to run scans on these things. But you can basically run different types of things like company Stalker, for example, will get email addresses in a particular domain. The footprint 1 through 3 are increasingly aggressive scans. And again, these things can be seen as aggressive actions. You don't take these on other systems. You don't do these things on other systems. But the idea is that you can conduct a footprint scan and you can type in a domain, in this case, stangernet.com. And I can run that on stangernet.com. That's my own network, and I can do that. And the idea is that, and I'm using the open source version, which is limited to 12 entities there. That's fine. If you pay for the fancier version, there are no limits other than technical limits. And the whole idea is that then it will conduct a scan. So Maltego, you could argue, is a visual Nmap on steroids that will go in and conduct all sorts of scans. And I'm going to cancel this particular one, but the whole idea behind these scans is that as you launch Maltego, and I won't save this, as you launch Maltego, it will go in and conduct DNS scans and all sorts of things, in addition to ping sweeps and all that sort of thing, to understand how a network works. Again, use only on your own system. The interesting thing is once you start something like Maltego, you do updates. You do updates of the database. In the same way for an antivirus system, you would do an update. Or for anything, you do various updates so that you get the latest version of it.
And then, James, just a couple questions that have come in. Would you consider NTOP-NG grouped with protocol analyzers like Wireshark?
I would consider NTOP-NG to be a network analytics tool. And you could argue, well, James, Wireshark is a network analytics tool. But Wireshark, again, it grabs packet captures and then shows all of those packets. Doesn't show the relationship between systems as well as something like a network analytics tool like NTOP-NG. And again, I'm profiling NTOP-NG because I find it useful. Is it the most incredible one out there? Probably not, but it's a very good one. It's open source too, which is nice. I like open source stuff because I think it works well. Second of all, it's free, and at least there is a free version of it available. So when it comes to the threat hunting, risk management, you have to understand that hacker lifecycle. You have to be able to start mapping tools to that mapping lifecycle. I spent most of my time on things such as Maltego and Nmap, which are reconnaissance tools. And Nmap, in a sense, not so much a reconnaissance tool, but a network analytics tool. But as you take a look at this, you're seeing in motion, I think, this is what I was trying to do, is the kind of red team, blue team sort of approach of analytics so that you can get situationally aware, so that you can understand the relationship between different protocols from a Wireshark perspective, but also how different systems work and play well together. And then you can start looking for those interstices, those gaps, as it were, and to identify, that's an area where we probably need to lock things down. And by lock things down, if you notice that end user seems to be targeted or there seems to be an issue with that, then end user awareness training. If you notice that there are some issues with how certain systems are communicating, well, maybe we need to update some patch levels. Maybe we need to create some more controls, like firewalling certain systems away even further from the live, raw, open internet. It's this sort of thing that as you do that kind of reconnaissance, either from a network analytics perspective, kind of an NTOP-NG, Wireshark perspective, or a red team, more of an Nmap, maybe Maltego, maybe other tools such as Security Onion and others. That's the type of thing that you have to think about. So I'm going to stop sharing this particular tool and get back to, here's another one real quick, DarkStat. You can look at that. It's kind of a fun little, very simple tool. In this case, DarkStat, it's a Linux-based tool. You install it on a Linux system. It has the ability to very quick and dirty look at patterns of traffic. And if you need to identify that there's a distributed denial of service attack going, sure, Wireshark can show you that. But this gives you a graphical perspective that I think your boss would appreciate more than just a bunch of packet captures. And so again, I'm not denigrating Wireshark. It's just using the right tool in the right situation.
Right. And then just a couple more questions, James. How are we doing on time? We're right around at the top of the hour.
We're right on the hour, yeah. So go ahead. I'm willing to spend more time if you folks are.
Okay. So one question was just a general question about, can we use these tools for penetration testing?
Yes.
Right.
You can. And again, don't do this unless you're authorized to do it, okay? But yes, they can be used as red team pen testing tools, sure.
Okay. And then does Maltego show the Tor network? I think you might have answered that in that it was just for a local network. So I just wanted to.
Well, no, you can Maltego would have, so would NTOP, really, NG. or there's NTOP, which is the older version. There's NTOP NG, which is the newer. All three of those would show a Tor network in progress, because in this way, they would show that there is a protocol in use. Now, it's possible that a good implementation of Tor network would anonymize things to such a point that it would be hard for them to trace that network, because Tor does two things: strong encryption of whatever you're doing, right? An encryption tunnel. It's like a little, it's a VPN, but it's also anonymized in that the connections are run in so many different areas and from one system to the other that it becomes difficult to trace them. But any good protocol analyzer can show that there is a protocol in use on the network. Nothing's truly invisible. It's just a question of, in other words, it might not, you may not be able to read it because it's encrypted, but you can show that, there's an encrypted protocol being used. And if you can see that an encrypted protocol is being used at 2 in the morning, and it looks like it's being anonymized, and you're pretty sure that nobody should be doing that on the network, you have an indicator of compromise happening there.
Great. And I think, unless I missed anybody, I think I've gotten to all the questions that have come in. So thank you, everyone, for submitting all those questions. And I, James, if you want to, finish up your presentation.
So, folks, what I can do is show some additional. I can cover some additional slides next time in regards to some of the stuff I wanted to cover. But next time, what I want to do is talking about essential networking skills so that you can understand when to use Wireshark, when to use something like NTOP, NG, when it comes time to using certain things. And so we'll be talking about essential network troubleshooting, network architecture approaches. We'll do some hands-on stuff there. Invite your friends. Here is the event. You can take a screenshot of it. You can Google for it. And I believe Leanne have to tell me that at the end of this session, I think this will be shown as an option for you.
Yeah, I put this into the chat window, the link to where you can register for the next event.
Thanks, Leanne.
Yeah. And then,
that's terrific.
Do you want to mention about the file transfer as soon as we're done here as well for the CE certificate?
That's right. The CE certificate will be available, and Mike Sutton, who is one of the enablers for this particular session, thanks, Mike, has made sure that certificate will be available.
Yeah,
so folks,
just stay logged on to WebEx once we wrap up here, and you'll see a file transfer box pop up that you can open up and download the CEU PDF for your CEU credits.
So, folks, we've taken a look at practical considerations of risk management. Talked a little bit about threat hunting. Rather than just waiting for an alert, you go out there and look for things. So you take an analytics perspective, a little bit of pen test, kind of red team, blue team. We took a look at the hacker lifecycle, folks. We look at some of the applications. I call them security applications. They have many uses. Again, these are things that you don't use unless it's on your own system and you have total authorization in writing. Talked about basically ways in which you can visualize different things, and a great discussion about, well, what about Wireshark versus NTOP versus something like Nmap, and different types of security applications and the way in which they worked. So, folks, we'll be talking about again specific networking tools. There was one question I noticed when it comes to the certificate that you get for the end of this session. Be careful that your pop-up blocker doesn't block the pop-up. So just make sure that you are able to get a hold of that. Make sure that you can refresh your browser and see if you can get it that way. Any other questions, folks? We're about 5 minutes over time, 4 or 5 minutes over time, but I don't want to lose any particular questions.
It looks like Anthony might be trying to enter in a question.
Okay.
I don't actually see. He just said quick question. I don't actually see the question that he's in. So we can find maybe.
And here's a sneak preview, folks, about some of the things that we'll be talking about next time. You know, what if you need to enable or disable IPv6 on an entire system in a Linux system, right? I'm getting right into the weeds here. What are some, you know, as you do updates on systems, whether it be Windows or Linux, how can you make those more efficient? Understanding things along those levels. Those are the things that, type of things that we'll be talking about next time.
Okay. And here's the last question that did come in from Anthony. He just wanted to know if you have a good reference list for what is acceptable to use and what is not for these tools.
Oh, no, I don't have a list for that, but what I would consider is when it comes to using these tools, if you're using them on things that you have, you know, in your home network, right, then you can use those tools all day long. The second, right, that you are using them on anybody else's system, then you have a problem. What is it? Your freedom of action. You're free to do anything you wish, but that freedom ends at somebody else's nose, right? You know, in other words, you can do anything you want, but the second it starts to affect anybody else in what would seem like the most trivial way, don't do it. So these tools can be used on local systems, but there you go. My right to swing, my fist ends where your nose begins type of thing. You know, so you cannot trip alarms, you cannot do various types of things. That, again, if it's another person's system, don't mess with it. And so using these tools, you can listen in on things. But at work, for example, I would not run Wireshark at work on my network for two reasons. One, it's probably a switch network, so you'll only be able to sniff stuff between your computer and the destination computer. That's first thing. You know, most hub-based networks, you can listen in on everything. Switch-based, you can't, unless you mess around with it. The second thing is it's not your network, so don't listen in on that. That's probably in violation of about 1,000 of the covenants that you signed for your acceptable use policy and any sort of implied things for your work. So don't do that. Do it at home on your own equipment. Otherwise, you can use those tools in any way you wish, as long as it stays on your own systems. Well, I think we're about 10 minutes after the hour. So, oh, good. Got people are getting the download, you know, because of somebody had a problem with a pop-up blocker. It happens a lot. So I want to thank you very much for this office hours with James. I'm willing to take suggestions, by the way, about certain topics, etc. Next time we'll be doing networking in April, but any sort of suggestions you have, happy to listen in on those. So again, thank you very much, everybody. Thank you, Leanne, for fielding the questions. Thanks, Mike, for setting up everything. And until April, have a great one, everyone. Bye-bye.